We want to try to write the number 2.317 repeating as a ratio of integers. So a ratio of integers, that is, we want to write this as a fraction, and in order to do it, we want to think of this as a geometric series. So to see it as a geometric series, we need the A and we need the R. So we'll take our 2.3 part of it, which is non-repeating, plus 0.17 plus 0.0017 plus 0.000017, and so on. Let's rewrite that as fractions. 17 over 100, 17 over 100, and a couple more zeros, and so on. So now we can look at this and say, okay, A is our first term, and then we've got our common ratio. So we want this part to be our geometric series. So here's our A. Oh, I think I'm off by a decimal place here. Yep, I'm off by a decimal place. So let's, like that, 0.0, throw an extra 0 in here, need an extra 0 in here, and some more zeros there. Okay, now are we good? 1/17,000th. So what do we need to do to get from here to here? What's our common ratio? Common ratio, R, is, we're multiplying this by 1 over 100 to get from here to there, from there to there. So we have our 2.3 out front plus our first term divided by 1 minus our R term. We can write the 2.3 as a fraction because the goal is to write it as a ratio of integers, so fractions. 23 over 10 for that first part. Plus, if we want to write this next part as a fraction, you can get a common denominator, do a little bit of algebra here. That on the bottom is 99 over 100, so I've got 17 over 1,000 times 100 over 99, canceling out some zeros. Looks like we have 23 over 10 plus 17 over 990. After you get a common denominator, you have it. You can type that in and use your fraction button on your calculator if you don't feel like working it all the way out. And now our repeating decimal is a ratio of integers. Next problem. Find the sum of the series where the absolute value of x is smaller than 1. So you're looking at this and you're thinking, oh, it kind of looks like a geometric series, but some things you should notice. First thing you should notice is here n starts at 0, and we've got a note with series. Zero to the 0 is equal to 1. Normally you would have to do L'Hopital's rule by changing the form and doing a limit and all that stuff. But with series, we're just kind of skip all that and make that definition. So we would like to write this as a geometric series, but it's not quite in geometric series form. Notice we can write 1 plus x to the first plus x to the second plus x to the third plus and so on. And this is, well, our a term is 1 over, common ratio is r, 1 minus x. You could have done this the same way if we had taken the 0 to the 0 term and done 0, not 0, 1, the 0 term, the sum from 1 to infinity of x to the n. Now here, what do we want? We want it to be x to the n minus 1. So if we want that, we could go 1 plus the sum from 1 to infinity of x times x to the n minus 1. Now it looks more like the definition that we used previously. And you're just going to have 1 plus a different fraction, which will simplify to what we just got. We can finish this up. Suppose a over 1 minus r. You get a common denominator, combine like terms. The x's in the numerator cancel out, and you're left with 1 over 1 minus x. Okay, so here, if you want to start with a n equals 0, you see it is still a geometric series.